Hello and welcome to Systems Integration. This session will address systems and user requirements. The method used in requirements collections and analysis will be discussed, and the importance of translating these requirements into system attributes will be addressed. Whether system or user requirements, they are defined as statements that explicitly define the expected function, behavior, and performance of certain features within a system. A requirements document can be developed to capture the goal of the system. Also, the document will have the features of the system and its components, the functionality of each component, and the behavior of components, and the overall system, including components' interaction with each other. The classification of requirements can vary based on different viewpoints. The most common classification is by the level of requirements, which can be classified into two levels: user requirements, and that's the high-level abstract requirements, and system requirements, and that's the low-level detailed description of what the system should do. In user requirements, users will describe different system functions in a natural language and regular statements. Users will describe services expected by the system. In addition, users will describe boundaries and constraints under which the system must operate. User requirements will be translated into system specifications, functions, services, and operational constraints. The translated detailed description of systems, functions, services, and operational constraints is called system requirements. So we have user requirements that will be translated into system requirements. The high level of description is user requirements, and the detailed lower and technical level is system requirements. The requirements will be written in different level of details based on the interested readers of those requirements. For example, there are readers of the user requirements who are not concerned with how the system will be implemented, such as client managers, system end users, and contractor managers. Other readers might need a detailed description of the requirements, specifications, functions, services, and operational constraints, such as system end user from the other side. Now we're not talking about the users of the system, but the end user from the other side, and those are the people who will maintain the system and be performing the back-end services and software development and design, and those who will be assisting in developing even the code that will be required to perform those functions and services. So we have users from the other end who will be interested on the system requirements. Systems requirements can be functional and non-functional. The functional requirements are tasks that are intended to be performed by the system and its components. Those tasks and how to implement them will be detailed in the system design. Functional requirements may be calculations, technical details, data manipulation and processing, and other specific functionalities that define what the system is supposed to accomplish. The non-functional requirements specifies criteria that can be used to measure the operation of a system. So we need to just judge or measure that operation. The plan for implementing non-functional requirements is detailed in the system architecture because they are considered significant. For example, in a network system, the network topology is non-functional requirement. And if you'd like, just search, if you don't know network topology, just search on the internet about the topology and it will show you what it means. So the topology is non-functional, but it supports the functional requirements. The non-functional requirements support the functional requirements. Functional requirements are expressed in the form system must do. They drive the application architecture of a system. Functional requirements will include all the features of a system, such as user interface, layout, and the reports that could be generated. While non-functional requirements are system shall be, and they drive the technical architecture of the system, and they describe how the system works, such as system policies or regulations. So the policies and regulations, they are non-functional, but they support the functional part of the requirements. Non-functional requirements arise through user needs because of budget constraints, organizational policies, the need for interoperability with other software or hardware systems, or external factors such as safety regulations or privacy legislation. The figure in this slide shows some types of non-functional requirements. To capture user needs and user requirements, different methods can be used, such as observation of existing system. So we put somebody in the system and they start observing how the system works, what are the processes, what kind of operations, what are the boundaries, what are the users, and they will document everything in that system. The other way to capture requirements is to interview subject matter experts, and those could be the power users, could be the developers, the designers of the previous system. We can interview them and collect the information and understand the requirements. We can create focus groups and brainstorming sessions where we can document the discussion between the people in the group and make sure that we can capture the requirements based on that. We can create checklists that will be verified by the power users. We can create questionnaires or surveys. We can use case studies also to capture those requirements. And we can use competitors analysis. So you can use as many methods as you need to ensure the collection of the correct information. You can use some of them, all of them. Most companies actually use all of these methods to collect user requirements and to confirm. Even if you used one method, the other methods will verify what was missed from the first method, and so on. This matrix lists some of the methods used to collect user requirements, their description, and their pros and cons. For example, user survey is quick and can address a large user group, but does not allow detailed comments, and you might not be able to follow up with the users. So again, as we said before, the mix of different methods will cover the gaps and shortcomings of these methods. We can see that there are shortcomings and there are benefits, so the shortcomings can be covered by other methods, and that's why we use multiple methods. User requirements will be analyzed to design and develop a system that meets the expectations of users and customers, which is critical to the success of the organization. User requirements analysis provides precise description of the content, functionality, and quality demanded by prospective users, and the attributes and characteristics of the system. Although you might be using multiple methods, collecting user requirements for a system requires a lot of effort, and the risk to fail is still very high. Consumers might not have an idea of the system functions required to provide the expected service. Accordingly, system designers and developers can assist in channeling the thoughts of the consumer or the end user to extract system functions. You must be creative to be able to do that, just to get the information from them. What do you need the system to do? What functions are you searching for? So creativity of the designer will be required at that point to transfer the user requirements into system functions and specifications. Although some systems will have the same goal, the design may differ from one system to another. For the development of professional applications, precise user requirements analysis and specifications is essential. It will be easy to analyze customer requirements and get the wrong results. Developers and designers must be careful of falling into not detecting these errors at the development stage. Verification process with the user or the client to ensure the interpretation of the analysis results or the what we collected was correct. And at that point we can minimize or eliminate any errors. Basically, you need to sit with the client and confirm each feature. Is this what you mean? Is this what you want the system to do? Is this the function that you're looking for? As collecting requirements, analyzing requirements also have many methods and techniques, and it's as important as collecting requirements. So this slide lists some of the common methods and techniques used in analyzing requirements. For example, the business process modeling notation, the unified modeling language and use case studies, and the flow chart diagram or techniques, data flow diagram, and all these methods can be used to analyze if we have a problem or an issue or a bottleneck at a certain point or a certain place. We can define the time for each process. And based on that, we can identify if there is a delay or there is a time that can be cut, or something can be used in that area to automate or to make it more efficient. We can use the integrated definition for function modeling. We can use the colored Petri nets. We can use gap analysis. As we said, we look at the current system and look at what we want the system to do, and then how we can close the gap and make it work. We can use object-oriented methods and treat systems as objects, and based on that, those objects and the components and the classes or attributes of these components can be inherited, and the specifications or characteristics will be determined. We can also look at the workflow techniques, the different techniques that is used to identify if there is a gap in those requirements. That will be all for this session. If you have any question, please let me know. Thank you and have a great day.